Welcome to solverfy.
So we know that we're going from the n equals 3 state to the n equals 2 state. So the energy values of these different n states are given by E sub n is equal to negative 13.6 eV over n squared. So E sub 2 is negative 3.4 eV, and E sub 3 is equal to negative 1.51 eV. For A, the shift in the energy level from the zero field value, delta E, is equal to mu sub B times the magnetic field strength B. So mu sub B is just a constant, 5.78 times 10 to the minus 15 electron volts per Tesla. And we're told the magnetic field is 1.4 Tesla. So this comes out to equal 8.11 times 10 to the minus 4 electron volts. Now for part B, to find the wavelength, we're going to consider the fact that E3 minus E2 is equal to delta E, or in other words, E3 minus E2 plus delta E. We just plug those values in, what we found for delta E, what we know to be E3 and E2's value, we get a value of 1.89 electron volts. So now that we know that, we can do change in wavelength here. So lambda minus lambda prime is equal to delta lambda by that same note. So lambda minus lambda prime, or in other words, delta lambda, is equal to hc, so because lambda is equal to hc over E. So we have hc times 1 over E minus 1 over E prime or we can use a little algebra to rewrite this in a nicer way. So hc times E prime minus E over E times E prime, or delta E over E times E prime. So we have this being equal to hc times delta E over E squared, if E is equal to E prime. So we're going to say here E is equal to E prime, and we're calling E 1.89 electron volts. So that value we calculated at the beginning is our E value, the energy difference, plus the zero energy level field. So we know delta E as well, because delta E is our 8.1 times 10 to the minus 5 electron volts. I wrote 10 to the minus 4, so this is supposed to be 10 to the minus 5. Some of you might have caught that mistake. So 8.1 times 10 to the minus 5. So this delta E value is the delta E value that we're using, and the E value we just calculated above is the E value we're using. And of course, H and C are just Planck's constant and the speed of light. So you plug those values in, and you find that this is equal to 0.0281 times 10 to the minus 9 meters, or 0.0281 nanometers. I'm going to write it in units of nanometers, but you could also write it as 10 to the minus 9 meters, since both are correct and equivalent. We'll box that in as our solution for B.